Hello everyone. In the last video, I have explained you how to calculate the ultimate load carrying capacity of the pile group. Piles are always used in groups and minimum number of piles will be 3 piles in a group. And in order to calculate the ultimate load carrying capacity of the pile groups, we would like to take one live example. The example is going to be to calculate the ultimate and safe load carrying capacity of a pile group. Piles data are given: diameter D equal to 1 meter, length L equal to 10 meter, and number of piles in a group equal to 4 piles. In a square pattern it is 2 by 2. And the ground condition is given to you. It is going to be cohesive soil, Cu equal to 30 kilopascal, and for soft soil, as you know, alpha is going to be 1. So alpha is also given in the problem. So how to calculate the Q ultimate? So we will see the solution of this problem now. So let us calculate the ultimate load carrying capacity of the pile group. So there are 4 piles. We can show it like this. This is the plan view. One, two, three, 4 piles. So n equal to 4, and it is in a square pattern, 2 by 2, right? And the sectional view can be shown like this. This is the sectional view. This is the ground level, and we need to find out the ultimate load carrying capacity of this pile group. So what is the formula? In order to find out the ultimate load carrying capacity of the pile group, it is going to be equal to number of piles in a group n multiplied by the ultimate load carrying capacity of a single pile into the group efficiency factor eta g. So number of piles here it is given 4. This you can find it out. Qu of single pile is given by alpha times Cu into pi dl, that is the formula, plus 9 times Cu into pi by 4 d square. So alpha being 1, Cu it's given here 30 kilopascal into pi, d is 1 meter, length of the pile is given to you as 10 meter, into 10 plus 9 into 30 into pi by 4 into d square. So if you calculate it, it is going to be 30 into 10, 300 pi. So we can find it out. 300 pi. So this term is going to be 942.47. 942.47 plus this term. So it is going to be 30 into 9, 270 into pi. So 270 into pi divided by 4. So it is 212. So this term, the second term is going to be 212.05. So 942, if you add 942.47, the ultimate load carrying capacity is going to be 1154.52 kilometer. So by using this equation, we are able to calculate this number of piles being known to you. So finally, we can calculate UUG. So let us calculate now the UUG equal to 4 into 1154.5 into eta g. This is based on individual shear failure. Based on individual shear failure, this formula can be used. Already discussed in previous video. Now, how to find out this group efficiency factor, eta g? So you have got converse Lebedev formula. So use that. So eta g can be found out from converse Lebedev formula. Eta g equal to 1 minus theta by 90 into m into n minus 1 plus n into m minus 1 divided by mn. So theta, let's say the center to center distance between the pipe is 3 times diameter. So it is 3 meter. So center to center distance between the two consecutive pipe is 3d. Therefore, theta equal to tan inverse d by center to center distance. This becomes 18.43 degree. So we can substitute eta g equal to 1 minus 18.43 divided by 90. M is the number of piles in a row. So number of piles in a row is going to be 2, and n is the number of piles in a column. So go to the plan view, number of piles in a column is going to be n equal to 2. So m equal to 2, n equal to 2, we can substitute and calculate it. So let's calculate the values. So eta g equal to 1 minus 18.43 divided by 90 into m is 2, n minus 1 plus n equal to 2 into m minus 1 divided by this. So this is going to be 2 to 4, and this is also 4, so this becomes 1. So if you simplify it, you get 18.43 divided by 90. You get the group efficiency factor as 0.795. That is, the group efficiency is going to be 79.5%. So this is the value of eta g. So we can substitute here the value of eta g, and we can calculate. So eta g will be replaced here by 0.795, and if you calculate, the value will be 0.795 multiplied by 4.5 into 4. So this is equal to 3,672.33 kilometers. This is the ultimate load carrying capacity based on individual shear failure. What is individual shear failure has been already explained to you in the previous video. So refer the theory, and you can calculate the ultimate load carrying capacity of the pile group based on individual shear failure. Now calculate the value of QUG based on block shear failure. So based on group shear failure or block shear failure, we can calculate it. So based on block shear failure, QUG is given as perimeter of the group multiplied by length into the skin friction Fs, and plus it is the area of the group multiplied by the unit end bearing capacity. So this is the formula based on block shear failure. So what is the perimeter of this group? This group, the perimeter is 4 times width of the group. How will you calculate the width of the group? There is 3 meters center to center distance, and d by 2 on this side and d by 2 on this side. It is going to be d equal to 1 meter. So 3 plus 1, 4 meter. So BG equal to 4 meter, and because it is a square pattern, the perimeter is going to be 4 times BG. So 4 into 4, that is 16 meter. So perimeter can be written as 16 meter. Length is going to be 10 meter, and the unit skin friction here, because the friction is going to be developed only on the periphery, it is always taken as Cu. So Cu in our case is going to be 30. So multiplied by 30 plus the area of the group here at the bottom. The area is going to be BG into BG. It is a square pattern. So BG we have already calculated as 4 meter. So 4 into 4, that is the area, 16 square meter, and this is going to be 9 times Cu. So 9 times Cu. So finally there is 300 into 16. So right, plus here 16 into 9 into 30 is 4,320 plus 4800. So finally you get 9,000 120 kilometer. So based on block shear failure, you are getting 9,120. Based on individual shear failure, you are getting 3,672. So lower value should be recommended as the ultimate capacity of the group. So ultimate capacity of the group, therefore QUG will be the lower one, 3,672.33 kilometer. This is the answer. And Q safe of the group safe load will be 3,672.33 divided by a factor of safety which can be taken as 2.5. So if you divide it by 2.5, you get it 14,001, 3,672. One four six eight 68.93 kilometer. That means more than 146, approximately 147 tons of load can be transferred safely. That is the so safe load carrying capacity of this group. So this is how you can do it. You can also take one problem based on triangular pattern. So if the number of piles equal to 3, so in the next example we will see how to calculate that. Here the group efficiency factor can also be found out using Feld's rule. So if we are going to use the Feld's rule, we can find out the alternative method of finding out eta G. So how to find out eta G? There are 4 piles. So what is the interaction of these 4 piles? That we can find it out. One interaction, another interaction, and the third interaction. So each pile are going to have 3 interactions. So all the 4 piles will have 3 interactions. So 4 piles, and the number of interactions should be deducted from 16, and it should be 1 by 16th time. So 4 into 16. So 1 by 16, and the number of interactions should be deducted from 16. So this becomes eta G. So 4 goes out, and this becomes 13 by 16. So eta G equal to 13 by 16. So if you calculate it, 13 divided by 16, you get it 0.812. There you got it 0.795. So where conversion Nevada formula in certain conditions you may not be able to apply it, you can apply the Feld's rule and you can calculate the group efficiency factor. Well, for example, let's say you have a triangular pattern, only 3 piles. So how will you use Feld's rule? So you can use the Feld's rule. Here there are only 2 interactions. So this. So there are 3 piles. Eta G for triangular pattern can be used 3 piles. 16 minus number of interactions, that is 2, divided by 3 into 16, 1 by 16. So 3 goes out. This becomes 14 by 16. So for triangular pattern, the value of theta g is going to be 14 by 16. That means it is 0.875. 0.875. So you can, sometimes at the site, you may require only 3 piles, and that is the minimum number of piles. Less than that you can't use. So that is how you can solve the problem. Thank you very much.